Right, grade 12s, in this lesson we're going to be giving you some information, maybe a picture, and we want you to find the actual equation of the cubic. So you're almost given the picture. So here's a first example. I'm going to give you fx is equal to, and I'm going to call this graph ax cubed plus bx squared plus cx plus d. It's a cubic graph, and I want you to determine its equation. I want you to find the values of a, b, c, and d if the graph passes through the following points. So the graph is passing through 6, 0, 0, negative 12, 1, 0, and negative 2 and 0. Now, if you think about this, let me show you something here. If I bring in a set of axes, let's just see what this graph looks like. It's cutting at 6, 0, so that's an x-intercept. Okay, so 6, 0 is your x-intercept. At 1, 0, it cuts. Okay, so and then also at negative 2. So what the graph is doing, and then it has a y-intercept at 0, negative 12. Okay, so it's at 6, 0 there, at 0, negative 12, 1, 0, and negative 2. So we want to determine the values of a, b, and c. So this graph, this cubic graph, is going to be cutting like this. So it's going to go down somehow like this, and it's going to come there. It's going to do something like that, turn, probably come up and do that. You're not really too worried about the turning points at this stage. So it's something like that. And so that's going to be 1, that is 6, and that is negative 2. And here you've got 0, negative 12. And you want to determine the equation of this graph given that information. Well, what we can do is, if you remember the trinomial factorized, you had a factor, so you really have 3 brackets. So what we do is we do it like we did with parabolas. We can say a into x minus the negative 2, x minus the 1, and x minus 6. Those were the factors, but we're just putting it into factor form. So that's a x plus 2, x minus 1, x minus 3, exactly in the same way. Remember, with a parabola, you would go x minus x1, x minus x2. It's the same thing, but we're repeating it with 3 brackets. And then you isolate an x and a y on the cubic, which happens to be 0 and negative 12. So let's put negative 12 in for y. The x goes 0. X is going 0 there. So this is negative 12 is going to give you a multiplied by 2 by negative 1 by negative 6. So negative 12 is positive 12a. Negatives cancel. 2 times 1 times 6 is 12. So a is equal to negative 1, which makes sense because the shape looks something like that. So all you need to do is plug it back. Minus 1 into the 3 brackets. X plus 1, x minus 1, and x minus 6. And if you want to, you can multiply that out if you so wish. So y would be negative. Keep it there. That's x. So we've got x plus 2, and then what we need to do is just simply multiply these two out. So it gives you x squared minus 7x plus 6, and then all we do is we then multiply like this. Okay, and let's see what we get. Okay, so it's x cubed minus 7x squared plus 6x plus 2x squared minus 14x plus 12. And then let's tidy that up. So y is equal to negative x cubed, negative 7, what have we got here? Negative 7x squared plus 2 is negative 5x squared. And then we've got 6 minus 14 is going to be negative 8x. And then we've got the plus 12. And then we simply multiply in, and there we've got it. And there you've got the equation of the graph that you wanted. Okay, what a pleasure. Let's look at a second example quickly, and we're going to do one where you've got a repeated x-intercept where it goes as a turning point on the x-axis. If your graph, if I give you an equation like this, now careful, watch this, it's minus x cubed, okay, plus ax squared plus bx, and I say minus 12. And I say to you that this graph passes through negative 3, 0, and has a turning point at 2, 0. So there's a turning point at 2, 0. Determine the value of a and b. What is the equation of the graph? Well, if you look at this, a turning point at 2, 0, what would that be? A turning point at 2, 0 is there, and it's cutting at -3, and it's sad. So it's definitely doing something, but it's going to definitely turn at that place there. So what we do is, when we do this thing, we go y equals a, x, now this is where -3 is, that's where 2 is, x minus -3, which is fine. Then we've got x minus 2, but we've got to repeat it because you're talking about cubics. So you repeat that bracket there as you did in the past. Now, I don't know about you, but I'm not certain what a is. Now, is there any way that we can maybe get a? Well, think about it. A would be the coefficient of x cubed, which is happening to be -1. Which makes sense, because if you multiply all of that out, the a comes in and it links to the x cubed. So we can say y is equal to, very simply put, -1 for the a, and then we've got x plus 3 and x, and this guy will be x squared minus 4x plus 4, if you multiply it out, and there we go. Okay, so y is going to be negative, then let's times that out, x cubed minus 4x squared plus 4x, and then we've got plus 3x squared minus 12x plus 12. Okay, and then if we tidy that up, we get negative x cubed minus x squared minus 8x plus 12, and then just simply multiply out, minus x cubed plus x squared plus 8x minus 12, and there's your cubic equation. Okay, very nice. Okay, so watch out, there's a repeat at the moment. You've got a turning point and an x-intercept that's the same. It turns on the x-axis. Okie doke, let us do a third example. Okay, in the third example, we're going a little bit more tricky. Okay, so bear with me on this one. What I want to do in example 3 is I'm going to give you the graph of fx is equal to ax cubed plus bx squared. And this graph has a turning point. So it has a turning point, and that turning point will be at 2, -4 on the graph. Okay. Now, if you think about this carefully, we've got a graph, and it's got a turning point. Somewhere it's got a turning point. Okay, I don't know what its shape is, but I know it's got a turning point somewhere. Okay, so maybe it will be that one there. That looks more appropriate, at 2, -4. Now, remember, the gradient of the tangent is 0 at that point. Okay, so what we know is that we've got some information here. We know that if you look at this, the f of 2, the x's to the y value is -4. We also know that the gradient at 2 is 0 because there's a tangent line. Now we're going to use this information to help us solve for a and b. So how do we do it? We can say, well, look, let's do the derivative first. F prime x is 3ax squared plus 2bx. Okay. Now, you want to find the gradient at x equals 2. So let's plug it in. And that's going to give you, what's that? 4 3s are 12a plus 4b. And of course, at a turning point, the gradient at 2 is 0. So we have 12a plus 4b. Maybe we can divide throughout by 4, making our life a little bit easier there. So hold on to that. It looks like it's some kind of a simultaneous equation. Now remember, that's because of the turning point that you could do that. But would you agree that this point also lies on the curve? So we can get another equation which says if y is equal to ax cubed plus bx squared, all we do is we're going to sub in that little 2 -4, and look what happens if that's your x and your y. So you've got y is ax cubed plus bx squared. Okay, so -4 is 8a if you cube plus 4b. Once again, let's get rid of the 4, divide everyone by 4. Okay, and there's another equation, which of course you can now go and solve for simultaneously. Okay, if you so wish. So let's see if we do it. You can use any different method that you want. Let's have a look. We've got 3a plus b is equal to 0. We can call that equation 1. And then we've got 2a plus b is equal to negative 1. We can call that equation 2. Now if I subtract these, in other words I change the signs because I'm subtracting, look here, then what happens is that you get 3a minus 2a is a, b minus b vanishes, and 0 plus 1 is 1. So there's a is equal to 1. Now pick any equation you like. Let's use this one, and we can say that that's 3a plus b is equal to 0, so b is equal to negative 3. There we go. So your graph would look like this. It would be, if you think of ax cubed, so it's 1x cubed, and then minus b, okay, x squared. Okay, great.